Okay, welcome back. This is this is video 2 that follows the video 1 about representing, naming, and evaluating functions. In video 1, we talked about different ways to represent a function, and also we talked about evaluating a function and using the results to come up with the range. In this video, we're going to look at exercises 2 and exercises 3. So let's take a look at these. The squaring function is defined as follows. Let f take x to y be the function such that x takes to x squared, where x is the set of all real numbers. Okay, so x, our domain, is a set of all real numbers. So all the numbers that don't have any imaginary numbers, right? So that's 2, 3, fractions, that's pi, irrational numbers, square roots and stuff like that too, okay? But you can see here we're focused on just a few kind of ideas. All right, so in this situation, right, any x value, to evaluate it, we're supposed to then square it. Right, so in other words, this is just like writing f of x equals x squared. Again, this is a strange notation that we don't really see a whole lot in a lot of the mathematics that we do. So I'll write that out for you. Let's evaluate these. So f of 0, well, again, the 0 replaces the x up here, right? And so we'll replace this x also as 0. So it's just 0 squared. What is 0 squared? Well, it's 0, right? Same thing for f of 3. Whoops, that's going to be 3 squared, which is 9. Okay. F of negative 2. Why don't you pause the video and go ahead and try this one on your own? And in fact, for the rest of these, why don't you go ahead and pause the video before I give you the answer and try it on your own first. Just go ahead and answer, what is f of negative 2? Okay, so hopefully you pause the video, and again, continue to pause for each new function evaluation. Try it on your own and then do it. Or feel free to try all of these on your own first and then just watch the rest of the video. Okay, f of negative 2 is going to be negative 2 squared, which gives us a positive 4. Now, if you typed into your calculator and you ended up with a negative 4 here, you need to be careful about how you type this in your calculator. In a graphing calculator especially, you need to put parentheses around something when you square it. If you just type in negative 2 squared like this, it's going to give you negative 4 in the calculator. You don't want that. That's not correct. When you square negative 2, it should be negative 2 times negative 2, which results in a positive 4. Okay? So let's just go ahead and continue with the rest of these here. F of the square root of 3, well, that's square root of 3 squared. And so we get 3. Okay, when you square a square root, they cancel out. And of course, you can see that in your graphing calculator and stuff like that too. Okay, f of negative 2.5, that's going to be negative 2.5 squared, which is positive 5.25. Okay, oh, yeah. So then we'll take a look here at the next one, which is 2/3. Oops, 5.25. I mean 6.25. Okay. Excuse me. And then f of 2/3. Well, that's going to be 2/3 squared. And when you square a fraction, you can just square the numerator and square the denominator, and so we get 4/9. As a decimal, that would be equal to 0.4 repeating, but this is really the preferable answer there. Now the next one is a little bit funky, right? We have a variable in there, a different variable than x. The x is replaced, the x up here, right, is replaced with an a down here. So what do we do? Well, again, same thing we've been doing. Replace the x squared with an a squared, and then you would just simplify. So a squared is, well, it's just a squared. That's our final answer there. Okay, and then the last one is 3 plus a. So again, this whole quantity is replacing this x up here. So we replace the x with a 3 plus a squared. Now, we can simplify this. So in some sense, you could just stop here and say, there's my answer. Okay, but we can simplify this a little bit more. We're going to use the idea that when you square something, you multiply it by itself. And we're going to multiply these two things out. Now you can use FOIL if you want to here, first, outer, inner, last. You can also just use the distributive property, right? This 3 has to multiply with that 3. This 3 has to multiply with this a. The a has to multiply with the 3. The a has to multiply with the a. And so we'll end up with 9 plus 3a plus 3a plus a squared. Or in other words, a squared plus 6a plus 9 when you simplify, right? Because those three a's are like terms. So this is also a good answer too. And it's important that you can do this as well for future lessons when we multiply that stuff out. Okay, lastly, what is the range of f? Well, this is interesting here. So these x values that we picked right here, right, that was not our domain. We were told what our domain was earlier. The domain is the set of all real numbers. Okay, so we have to think here, right, if we take any real number, okay, what are all the possible range or y values that could, result? Well, this is a good question, right? So, are there any y values we won't hit? Could we just say that the range here is all real numbers? Think about that for a second. Are there any y values that are going to be impossible? Okay, our function here is we are squaring something. So is it possible that when you square something, that you'll never get a particular kind of number? And I'll give you a hint. Look right here at this. What happens when you square a negative number? Negative 2 times negative 2 became a positive 4 there. Is it possible to square a number and get a negative answer? Not with real numbers. So it's not all real numbers because negatives are impossible when you square them, right? Again, this is our function. We're squaring things. So it's not all real numbers. It's going to be all real numbers greater than or equal to 0. We can get 0 if you square 0, right? 0 squared is 0. We see that right here. So that's the lowest y value, the lowest range value we'll have. But otherwise, we'll have positive numbers too. So it's going to be all real numbers greater than or equal to 0. Okay. You can also describe the range as, y is greater than or equal to 0, like that. That's another way to write it too. Okay. You could also use interval notation. So you can start at 0 and then go to infinity. Like that, where we include the 0 and we exclude infinity. All right, let's move on here. What subset of the real numbers, so subset just means a smaller set inside the real numbers, a smaller group of numbers inside the real numbers, could be used as the domain of the squaring function to create a range with the same output values as the sequence of square numbers from lesson 9. So we only want the square numbers, right? Nothing else. So what kind of numbers, when you square them, will result in these answers right here? Well, it's easy. The domain would have to be, sorry, it's not easy. I apologize. We have to think about what numbers when you square them give you this. So what number when you square it gives you 1? Well, 1 does, right? What number when you square it gives you 4? 2. What number when you square it gives you 9? Well, 3 and 4 and 5. And you can kind of see what's happening here, right? These square numbers, right, are a result of just squaring all of our counting numbers. So it'll be like 6, 7, 8, 9, so on and so forth, 10, 11, 12. That would be our domain. Okay? All right, let's take a look at exercise 3 here. Recall that an equation can be either true or false. Using the function defined by this right here, such that f of x, or such that x takes 2 to the x, like that. So in other words, determine whether the equation f of x equals 2 to the x is true or false for each x in the domain of f. So we're basically going to plug all these x values in to our function right here and see if they result in these y values for the range. Okay, so again, try this on your own, pause the video, do it on your own first, and then come back and you see the answers here. So this is a lot of justification to do right here. I'm not going to do this same justification for every single problem, okay? We'll use it as we need to. So anyway, is the equation f of x equals 2 to the x true or false? Let's see. So I'll do 2 to the 1, which gives me 2. Is 2 in my range up here? And the answer is yes, it is, right there. Okay, so true. Okay, and again, I'm not going to do this whole justification. You can see, instead of saying substitute in 0, we will sub in 1. F of 1 equals 2 to the 1, and, 2 equals 2, so check. They're the same, okay? So it's kind of silly. I'm not going to do it for all that, nor do you need to do that. Okay, 2 to the 2 is 4, and 4 is in our range up here, so true. Okay, 2 to the third equals 8, which is in our range up here, so again, true. 2 to the 4, 16, it's in our range up here, so that's again true. And then 2 to the 5 is 32, so again, this one's also going to be true. All right. If the domain of f were extended to all real numbers, would the equation still be true for each x in the domain of f? Explain your thinking. So, it looks like they're asking us here to change the domain of f, but it did not ask us to change the range. So in other words, we're going to change the domain so that it's all real numbers. So, our domain's going to be, -2, like 0, 1/2, pi, all these numbers here. Okay, if we extend the domain to be all real numbers, and not the domain that they give us right here, where it's just this limited domain, okay, will our function still hold true? Well, our range here is not going to have all the correct answers from our original domain. And so the answer is going to be no. The domain of all real numbers will not match to the given range of 1, 2, 4, 8, 16, 32, and 64. And here's an example, right? You can just use, I don't even say 1/2. I mean, let's just say, well, sure, let's just say 1/2. Okay, so let's do like f of 1/2. That would be 2 to the 1/2 power, which is equal to the square root of 2. And the square root of 2 is not in that. Okay? All right, I will stop there, and I will do the next 2 exercises in the next video. Thanks.